Welcome back to Chapter 2. In this section, Section 4, we are going to be looking at real zeros of polynomial functions. So far we've been looking at polynomials and monomials and quadratics and graphing and doing a lot of stuff like that, but now we're going to start the part of the chapter where we're looking at finding the zeros, the roots, the x-intercepts, the solutions. It sounds like a lot, but those are just synonyms. A synonym is a word you use when you forget how to spell the other word. So I give you a few options. Our learning targets. We're going to see how to divide polynomials. We're going to use the remainder and factor theorems to find remainders and factors. We're going to find linear factors of polynomial functions, and find polynomial functions satisfying given conditions, and then use the rational zeros theorem to find zeros. So the first part is polynomial division. The good news about polynomial division is it's basically the same thing as long division. The bad news about polynomial division is, from my experience, you probably don't remember how to do long division. So we're going to give a little recap here on how to do long division. The first thing we need to do is we need to write it in long division form. So the 32 would come out here, then we have our division sign, and the 3, 5, 8, 7. There's a reason why I started it as a fraction instead of like this, and that reason is because I could not find the division sign in the equation editor. There we go. So in long division, we're going to take this number and see how many times it can go into each of these. So we start out with 3. How many times does 32 go into 3? Well, it doesn't. All right, let's add another number. So how many times does 32 go into 35? Well, that would be 1 time. Then we multiply. 1 times 32 is 32. Subtract. 35 minus 32 is 3. Bring down the next number. How many times does 32 go into 38? Also 1 time. Multiply. 32. Subtract. 38 minus 32 is 6. Bring down the next number. How many times does 32 go into 67? That would be twice. Multiply. We get 64. Subtract. And we get 3. 3 would be the remainder. Now there's different things that we do with the remainders. When you first started out, you'd have r equals 3 for the remainder equals 3. We can make it a fraction. So the answer is 1/12 and 3/32. We could put a decimal point, bring down another 0, and start and keep dividing to get 112 point what. But right now the fraction will work because that's really what we're going to be doing. So our answer here to our division problem is 112 and 3/32. So how does that work with a polynomial? We have this. So the first thing we need to do is we need to rewrite it the same way. So we're going to have 3x plus 2, and we're going to be dividing 3x cubed plus 5x squared plus 8x plus 7. All right, so now for this first part, we only have to look at our first term. We're looking at this 3x. And we can divide, but sometimes it's easier to think what times this. Like, so 3x times what equals 3x cubed. We could divide, we could go 3x cubed divided by, like, how many times does 3x go into 3x cubed? That is a little bit harder to think about. But 3x times what equals 3x cubed? Well, we already have the 3, so then the x, to get x cubed, we need x squared. All right, now take that and multiply to the whole thing. 3x squared, or 3x times x squared is 3x cubed, and then 2 times x squared is plus 2x squared. We subtract, just like we did with our numbers. So the 3x cubed, that goes to 0. If that does not go to 0, it means you made a mistake. 5x squared minus 2x squared. Do you think that forgetting to distribute that negative is going to be a common mistake? I think it's going to be a common mistake, but that's only because of experience, don't forget to distribute the negative sign. So we have 5x squared minus 2x squared is 3x squared. Bring down the next piece. You could bring down the whole rest of it if you want. It doesn't matter. Now 3x times what equals 3x squared? Well, again, we already have the 3. So we'll get, so we already have the 3, so we need x. So we have x times x will equal x squared. Multiply. 3x times x is 3x squared plus 2x. Subtract. When we subtract, 3x squared minus 3x squared is 0. That goes away. 8x minus 2x is 6x. Bring down that 7. Now 3x times what equals 6x? Well, the 3 times 2 would equal 6. We already have the x's, so we'll get plus 2. Multiply. 3x times 2 is 6x. 2 times 2 is 4. Subtract. 6x minus 6x is 0. 7 minus 4 is 3. And so 3 is the remainder. So we could have plus 3 over 3x plus 2. Now, so something to notice about these two, the numbers we used were the same. 3,587, we had 3x cubed, 5x squared, 8x, 7, and then 32, we had 3x plus 2. Notice the answer, the numbers were the same. Like this process, it was the same. You can see the same numbers in every step going down. That's why I say that dividing polynomials is the same thing. It uses the same algorithm as dividing numbers. Let's do another one. So let's take 2x to the fourth minus x cubed minus 2 and divide that by 2x squared plus x plus 1. So this one's a little bit bigger. So we're going to go 2x squared plus x plus 1. And what we're dividing, we have 2x to the fourth minus x cubed. And then we skip the x squareds and the x's. You could put plus 0x squared. You could leave a space. I would do one of the two. I would not just put that minus 2 right on there because everything's going to get bunched up in the work. So I would either write it out, plus 0x squared plus 0x minus 2, or leave room for that to begin with. All right, now same idea. We're going to take just that first term, 2x squared times what equals 2x to the fourth. We already have the 2, so x squared, we need to multiply by x squared. Now we can multiply that out to the whole piece. 2x squared times x squared is 2x to the fourth. X times x squared is plus x cubed. 1 times x squared is plus x squared. Subtract 2x to the fourth minus 2x to the fourth, 0. Negative x cubed minus x cubed is negative 2x cubed. How many of you saw that and thought, oh, hey, that's going to cancel out too? Don't forget to distribute the negative. When it's like that, where you have the same thing in a positive and negative and it would cancel out, it's really tempting to forget to distribute that negative. Don't do it. Don't be that guy. Then 0x squared minus x squared is negative x squared. We can bring down the rest, plus 0x minus 2. All right, so how many times does 2x squared go into negative 2x cubed? Well, we need that negative, so it'll be a negative 1. And then the 2's there, x squared to x cubed is just another x. Multiply. So we have negative x times 2x squared is negative 2x cubed. Negative x times x is minus x squared. Negative x times 1 is minus x. Subtract. The negative 2x cubes cancel. Negative x squared minus negative x squared. Hey, that one does actually cancel. And then 0x minus negative x would just be plus x minus 2. All right, now what we have here is this degree is a degree of 1, it's less than this degree up here. Once your degree is less than what you're dividing by, that's your remainder. So we have x squared minus x plus x minus 2 over 2x squared plus x plus 1. And that is the remainder. So that's another example of how we do the polynomial division. Now, when we do divide, we get what's called the division algorithm for polynomials, or sometimes it's called, I don't know, it's an equation. All it says is that the function f of x, that's what we start with. That would be the numerator of our fraction there, equals the divisor, that would be the denominator of our fraction, times the quotient, that would be the non-remainder part plus the remainder. So if I wanted to rewrite what we just had, that would be 2x to the fourth minus x cubed minus 2 is going to equal 2x squared plus x plus 1 times x squared minus x plus x minus 2. So it's just plus the remainder. We don't need the remainder to be over something. If we just took this row and multiplied it by the d of x, it would cancel the denominator and the remainder, and so it would work out. But here we don't need it because it's already outside of that multiplication. Every once in a while they get a problem that just has you use this equation somehow. Don't be scared of it. It's just the same stuff that we have, just rearranged. Usually it would just have you write it in that form, if it's using that at all. So now the remainder theorem. What the remainder theorem says is if a polynomial is divided by x minus k, then the remainder is f of k. So basically what we get when we divide by a linear polynomial is the same thing as if we plugged in that value. So let's test that out. We have a function f of x equals 3x squared plus 7x minus 20. Let's find f of 2. We'll find it with the division, and we'll also find it by just plugging it in. So first let's start out with the division. So it's f of 2, so we're going to divide by x minus 2, and we're dividing 3x squared plus 7x minus 20. 3x squared plus 7x minus 20. So x times what would give us 3x squared? Well, we need a 3, and we need an x. Multiply, gives 3x squared, then minus 6x. Subtract, the 3x squareds go away, 7x plus 6x is 13x minus 20. X times what is 13x? That would be plus 13. Multiply, we get 13x minus 26. Subtract, 13x's go away, negative 20 plus 26 will be 6. So what it's saying is that f of 2 will equal 6. Let's try that out. Let's plug in f of 2. This is called finding it numerically, by the way, by just plugging it in. So we get 3 times 2 squared plus 7 times 2 minus 20. So 3 times 2 squared is 4, times 3 is 12, plus 7 times 2 is 14, minus 20. 12 plus 14 is 26 minus 20 equals 6. Look at that. It works. It's the same thing. Let's do it again for f of negative 4. So here's one. You can try this one. You could pause it now and try. You can wait till you get it set up and then try, but I would try it. See, like practice it. See what we're doing. So f of -4, so we have to plug in x minus that number. So this will be x plus 4. And we still have 3x squared plus 7x minus 20. So x times 3x is still 3x squared. Multiply, we get 3x squared plus 12x. We're going to subtract that. So 3x squareds go away. 7x minus 12x is -5x. Bring down that 20. So x times what is -5x? That would be -5. Multiply. We get -5x minus 20. Subtract. And we get the -5 minus 5. That goes away. -20 minus -20 goes away. So we get 0. So f of -4 here equals 0. Let's test that out. F of -4 is going to be 3 times -4 squared plus 7 times -4 plus 20. So -4 squared is 16 times 3 is 48. 7 times -4 is minus 28. I put plus 20. This is a minus 20. Minus 20. Well, 48 minus 28 is 20. Minus 20 is 0. So we get that it equals 0. So again, dividing by that linear binomial gives us the solution. It's just whatever that remainder is actually the value if we plugged it in. Now you might be thinking like, yeah, but it's actually easier just to plug it in. True, right at this moment. However, that's not always the case. I'm going to show you a quicker way of dividing here pretty soon, later on in this lesson. And by dividing, it also helps to take down the fraction. So now we have, or not the fraction, the thing. We have, instead of a quadratic, we'd have a linear function now. So that's something else that gets helped when we actually do this division. It's called synthetic substitution. So we have a factor theorem. The factor theorem says that a polynomial f of k has a factor x minus k if and only if f of k equals 0. So if there's no remainder, if it divides evenly, it's a factor. So -4 in that last one was a factor because we had a remainder of 0. And then fundamental connections. It's a solution or root. If it equals 0, it's a 0. It's an x-intercept, or it's a factor. Those again are the synonyms that I mentioned earlier. They mean the same thing. Sometimes, depending on the situation, one of them makes more sense to use, but they all do mean the same thing. All right, so let's look at an easier way to divide. This is called synthetic division, and it does come from the regular division. It's just shortened. We take out all the extra stuff, and we work specifically with just the numbers. So let's divide 2x cubed minus 3x squared minus 5x minus 12. And so now synthetic division only works if you're dividing by a linear binomial, specifically x plus or minus a number. It's possible to do it if you had like a number times x plus or minus a number. It takes a little bit of tweaking, but it can work. But we use it specifically when it's like dividing by x minus 3. So what we do is our division looks a little bit different. It's going to go that way. We're going to take what we're dividing, and we're going to take only the coefficients. So we're going to have 2, -3, -5, -12. And what we're dividing by, we take just that number. And now, so this is again x minus a. We take the a, so in this case it's x minus 3. So the 3 goes there. So whatever it is, you have to change the sign. If it was x plus 3, we'd need a negative 3. And now for this division part, this first number is going to go straight down. It's going to go right down to there to be a 2. And then we're going to multiply by this number to get the one that goes up there. So 2 times 3 is 6. And then to bring it down, we add. Negative 3 plus 6 is 3. Now again, we're going to multiply. 3 times 3 is 9. Add. Negative 5 plus 9 is 4. 3 times 4 is 12. Negative 12 plus 12 is 0. So here we had a remainder of 0. Now, that was going slow as I was explaining it. You will be getting very, very quick at doing this. If we set it up, we can do the same one. Negative 5, negative 12. So we bring down the first one, we multiply, add, multiply, add, multiply, add. There. That's what we do. So what we get this, what this tells us is we're going to have 2 and we're going to have some x's. We look at what that initial degree was, subtract 1. So this is 2x squared. And then plus 3x, we just go down 1 each time, plus 4. And then there's no remainder. We could say that this times x minus 3, that equals this upper equation. So let's do another synthetic division problem. Here we have 4x to the 5th minus 3x squared plus x divided by x plus 2. So when we set it up, x plus 2 means this is a negative 2. And now we start out with to the 5th. Now it's important that our monomials are in decreasing order. So we start out with the biggest and we go down to the smallest for degree. So that leading coefficient's 4, x to the 5th. And now we cannot skip any. So we need x to the 4th. There's 0 of those. X cubed. There's 0 of those. X squared. There's negative 3. X, there's 1. And a constant. There's no constant. So it's very, very important that we keep those zeros because the placement is the only thing that tells us where that number goes, like what term it goes to, because we have taken all those x's out. So we have this, we're going to bring that 4 down. Multiply by negative 2 gives us negative 8. Add is negative 8. Multiply by negative 2 gives us 16. Add is 16. Multiply by negative 2 is negative 32. Add is negative 35. Multiply by negative 2 is 70. Add is 71. Multiply by negative 2 is negative 142. And add, we get negative 142 would be the remainder. So if we wanted to write this as a polynomial now, we would have 4x to the 4th, because we started out with 5, we have to get rid of 1 because we divide by that linear coefficient. Then minus 8x cubed, just go down 1, plus 16x squared, minus 35x plus 71, then minus 142 over x plus 2 because that's our remainder. So we can use synthetic division for that. Most of the time when we use it, we're going to be checking to see, is this a factor? If it's a factor, what's going to happen is that number is going to be 0. Like this one is not a factor. It did not divide evenly. We have that remainder. And so a lot of times we can tell pretty early whether or not that's actually going to get down to 0 or not. Like this one, those numbers just kept getting bigger and bigger, so it wasn't going to be 0. But we're just looking for 0. So if this was what we were doing here, we would have gotten down to like, oh, negative 142. Nope, this isn't a factor. Let's try another one. And so what do we know, or how do we know what to try? We know what to try based on the rational root theorem, which tells us if f is a polynomial with a degree bigger than 1, we have our polynomial, then the so p is an integer factor of the constant, and q is a factor of the leading coefficient. Then the factors, all rational factors, will be of the form p divided by q. So this will narrow down what our factors could possibly be. Now it might narrow it down to like 8 or 20 or 24, but that is lower than the infinite number of factors that we start out with. So it does help. To lower it down further, we can actually find some upper and lower bounds. If we do our synthetic division with a positive value, so we'd have like x plus 2, and that bottom line, everything was either positive or 0, that means that that 2 is going to be an upper bound. If we have a negative number or 0, and all the numbers in that line are alternating, non-negative and non-positive, then k is a lower bound. So that can help us out. Specifically, if you plug in 0 and you just get like plus, minus, plus, minus, plus, minus, then you know that you're not going to have any negatives that you're going to have to worry about. So how does this work? We have this guy. We have f of x equals 3x cubed plus 4x squared minus 5x minus 2. So all of them are going to be p's over q. P is a factor of the constant. That would be negative 2. So factors of negative 2 could have plus or minus 1, plus or minus 2. Q are factors of the leading coefficient, which could be 1 or 3. Yes, technically it could be plus or minus as well, but I've already covered the plus or minuses with the p's. So our possible roots, our possible rational roots, we can have roots that are not rational, but our possible rational roots, we're going to have plus or minus 1 over 1, so that'd be 1, plus or minus 2 over 1, plus or minus 1 over 3, and plus or minus 2 over 3. So we have a total of 8 possible things that we could try. Well, I generally start with the easy ones. Start with plus or minus 1, plus or minus 2, and then you can get into some of the other ones. So let's start with just 1. So we have 1, and then synthetic division, we have 3, 4, negative 5, and negative 2. Bring down the 3, multiply, we get 3, add is 7, multiply is 7, add is 2, multiply is 2, add is 0. Oh, hey, 1 is a root. So we know that works. Now we don't need to do any more, because what happened here is we started out with a cubic. What we have now is a quadratic. So we have 3x squared plus 7x plus 2. We have other methods of dealing with quadratics. We can factor those. We can use the quadratic formula. So once you get it to a quadratic, do something else. Don't keep guessing and checking. So we have that, and then I'm going to put times x minus 1. So we still have our polynomial here. And so this one, I believe, will factor, because we'll have a 3x and an x, and then a 2 and a 1, We need to multiply one of them by 3 and then add to get 7. Let's multiply that 2 by 3. So we have 3x times 2 is 6x, plus 1x is 7x. So we could factor our f of x to get this, which means our solutions, we have x equals negative 1/3, negative 2, and positive 1. So we only needed to guess 1. Now, if I came out to a different value, I would have tried another one. So let's do another problem here. Let's find the rational roots of 2x to the fourth minus 7x cubed minus 8x squared plus 14x plus 8. We're actually find all the roots of this. So our p's are going to be the factors of 8, which could be 1, 2, 4, and 8, plus or minus. And then the q's are the factors of 2, which are 1 and 2. So our possible roots will have plus or minus 1 over 1, 2 over 1, 4 over 1, 8 over 1, and then 1 over 2, 2 over 2, which is just 1, we already have that, 4 over 2, which is 2, we already have that, and 8 over 2, which is 4, we already have that. So we end up with 10 possible rational root options. So let's start. I'm again going to start with 1 because that's the easiest one to start with. Let's see, then we have 2, negative 7, negative 8, 14, and 8. So bring it down, multiply, add, multiply, add, multiply, add, multiply, add. So it was not 1. We can count 1 off our list. Let's try negative 1. So we still start with the same values. So we bring it down, multiply, add, multiply, add, multiply, add, multiply, not 0. So it won't be negative 1. So we can cross both 1 and negative 1 off of our list. All right, well, let's try 2. So we'll have 2. Let's go 2, negative 7, negative 8, 14, and 8. So bring it down, multiply is 4, add is negative 3, multiply is negative 6, add is negative 14, multiply is negative 28, add is negative 14, multiply, that's not going to work, so it won't be 2. Let's try negative 2. 2, negative 7, negative 8, 14, and 8. So bring down the 2, multiply is negative 4, add is negative 11, multiply is 22, add is 14, multiply is negative 28, add is negative 14, multiply is positive 28. Not going to work, so won't be 2. Now we could try 4 and 8. I'm kind of leaning to 1/2, although no, let's do 4 first. My guess is it's probably not going to be 1/2. So 4, let's see, 2, negative 7, negative 8, 14, and 8. Bring down the 2, multiply is 8, add is 1, multiply is 4, add is negative 4, multiply is 16, negative 16, add is negative 2, multiply is negative 8, add is 0. Hey, we found one. 4 works. Excellent. So now, from this point out, we use this one. That's a cubic. So we're going to use that one. And we can readjust our possible roots as well, because now this one has to do the same p and q. So our p's are now 1 and 2, and the q's are 1 and 2. So that means that we're not going to have 8, we're not going to have a 4 again. We know that we're not going to have these guys. We already tried those guys. Let's go to that 1/2. So let's do a positive 1/2 here. So we bring down the 2, multiply by 1/2 is 1, add is 2, multiply by 1/2 is 1, add is -3, multiply by 1/2 is -3/2. So this is going to not be 0 here. All right, so let's try -1/2. And still with the 2, 1, -4, -2. See, this is the whole deal with as opposed to guessing all of them, we do, instead of the just substituting to see if we get 0, we do this because we end up breaking down the function, breaking down the function into smaller and smaller degree functions. So bring down the 2, multiply times -1/2 is -1, add is 0, multiply is 0, add is -4, multiply is 2, add is 0. So -1/2 works, and what we have left is 2x squared plus 0x minus 4. That's quadratic. Equals that, and then times x plus 1/2, x minus 4. We can deal with that quadratic. Now it's not going to factor very well. However, we know that 2x squared minus 4 is going to equal 0. We can add the 4, divide by 2, so x squared equals 2. So x would equal plus or minus root 2. So we could write our function as x plus root 2, x minus root 2, x plus 1/2 times x minus 4. So that would be writing the function as a product of linear binomials. That's what that means. You just take your factors and you write it out. If you know what the zeros are, if you know what the roots are, if you're looking at a graph and you can see them, you can write it like that, and that's your function. Maybe you have to multiply it out to get it in standard form, but that's your function. You just start out with your factors from either, hey, the roots are this, 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 and this, or by looking at the graph, you see the roots are this, 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 and this. Put it into your factors, and then multiply. And so our roots here, we'd have plus or minus root 2, 4, and -1/2. So that is using the rational root theorem. That's using synthetic substitution. I went through basically all of my roots before I got there. Hopefully you guys don't have to try every single one of them before you get the one that you're looking for. But if you do, hey, I did. It goes a little bit quicker. Anyway, this is something that you did see last year in Algebra 2. And we will continue to use it. We'll continue to do it. We will use it more in calculus as well. I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.